In this video, we are going to find the area of the region bounded by x plus y equals 5, y equals 2x, and y equals 0. So to get started, let's draw our arbitrary rectangle. And we'll first compute dA. So dA is a length and a width. So our length we'll put in here. So we're going to have a length and then a width. Remember, our width is dy. So our width is dy. And that's this little width right here, dy. Now for our length. So remember, we need these two lines written as functions of y, not as functions of x. This is written as a function of x. You put an x value in, it gives you a y value out. So to write it as a function of y, we need to solve for x. So solving for x, we have x equals y over 2. So I'll put that in over here. X equals y over 2. And solving for x here, we get x is equal to 5 minus y. And remember, we want right minus left. So the rightmost function is 5 minus y, minus the left, y over 2. So my dA, let's simplify a little bit. So we have minus y minus 1/2 y. So combining like terms, we have minus 3/2 y. So 5 minus 3/2 y dy. So that's the area of my arbitrary rectangle, the arbitrary blue rectangle there. Right, so now the area, right, the actual area, this is going to be the integral of dA. Now we need to tell the integral where to start and where to stop. So if we're integrating along the y-axis, this is where we start. We start at 0 and we stop right there. So that'll be the question mark. Where do we actually stop? Now remember, from the previous video, we found that these two functions, x plus y equals 5, or lines, these two lines, x plus y equals 5 and y equals 2x, they cross when x is 5/3. So if they cross when x equals 5/3, then to find the y value where they cross, we can just plug x into either one of these two functions or lines, same thing. Okay, so if the x value is 5/3, then the y value is 2 times 5/3. So I'm just plugging it into this function here. So that's 10/3. And so now we can compute this integral to find the area. So our area equals 0 to 10/3 dA, which is the integral from 0 to 10/3. Remember, dA was 5 minus 3/2 y dy. So antiderivatives, we have 5y minus 3/2 times y squared over 2, evaluated from 0 to 10/3. Simplifying a little bit inside these brackets, I'll write this as 5y minus 3/4 y squared, evaluated from 0 to 10/3. And now plugging in our values, we have 5 times 10/3 minus 3/4 y squared. So we're going to have the square of 10/3 minus, now plugging in the zeros, right, we're going to get 5 times 0 minus 3/4 0 squared. That's just going to be a bunch of zeros, so we'll get rid of that. All right, so this is going to be 50 over 3 times, minus 3/4 times 3/4, not 3/3, times 100 over 9. Okay, so 3 goes into 9 3 times, 4 goes into 100 25 times. So we have 50/3 minus 25/3, that equals 25/3. And that's our area.